Hey, it's Professor Gould. In this section, we're going to talk about what happens within water to create acids and bases. So acids and bases are created because within water, some of the water molecules break down. They separate into different functional groups. Hydrogen ions, H+, meaning that the hydrogen has given up its electron, and OH-, hydroxide ions. The OH has taken the electron from hydrogen. So these have actually formed ions, meaning that you could think of water as ionic bonds, but don't. Those are covalent bonds. Anyway, they sometimes act like ionic bonds because in biology and in chemistry, everything is so much more complicated than you think it is. Okay, so anyway, we sometimes separate these two, or we don't, they separate each other into ions. In pure water, when there's nothing else but hydrogens and oxygens, there are equal numbers of hydrogen ions and hydroxide ions. And so we say that it has a neutral charge. It's not a positive charge, it's not a negative charge, and we say that it is a neutral solution. Now, in most fluids, in most aqueous solutions, there's actually something else in it. And it may just be the minerals that leached from the pipes that carried the water. But there are very few things that are pure water. It's actually really hard to get pure water. So most things are slight acids or slight bases. Acids have more hydrogen ions in the solution. Bases have more hydroxide ions in the solution. When we measure whether something is an acid or a base, we aren't actually measuring how many hydroxides there are. We are only measuring the number of hydrogens. So we say that acids release hydrogen ions and bases absorb hydrogen ions. In doing that, they make more hydroxide ions, but we're not counting the number of hydroxides, counting the number of hydrogens. So they're going to absorb more hydrogens. Okay, so that's an important key to remember. Now, we measure acids and bases on what we call the pH scale. This is the proportion of hydrogens. That's why it's pH. Lowercase p, uppercase h. If you have autocorrect on your computer, it's going to make it uppercase p, lowercase h, and that's wrong. This is one where you're going to have to go in, either turn off autocorrect for pH, or go in and correct it by hand. It's really annoying. Anyway, this is measured on a logarithmic scale. So on a logarithmic scale, the difference between 6 and 7 is 10 times. The difference between 7 and 8 is 10 times, okay? 7 is neutral, and then we go up and down from there. It's also a negative logarithmic scale, so more acidic has a lower number. Urine is slightly acidic. Actually, the pH of your urine can change wildly depending on the acidity or alkalinity, that's the word we use for basic, of your diet. The pH of your urine is completely irrelevant. It means that your kidneys are doing their job of filtering excess acids and bases out of your blood. Okay? If anyone tells you, oh no, your urine is acidic, that means you're sick, they are full of BS. Sorry, pet peeve. Coffee, tomato juice, grapefruit juice, and soft drinks are more acidic. Lemon juice is actually very, very acidic, and if you just leave it on your skin, it will start to eat away at your skin. If you've ever gotten it in a cut, you have felt the effect of a strong acid on a cut. Battery acid, very, very strong acid. Very strong acids are dangerous to living tissue. Your stomach can handle very strong acids because your stomach is full of a very strong acid. For those of you wondering, then, how does your stomach survive? There's two things in your stomach that happens. One is that your stomach has a thick layer of mucus, which protects the cells from the stomach acid made by the stomach. The other is that it actually doesn't completely protect your stomach, and you actually do break down the cells lining your stomach and you digest those. So a lot of the stuff going through your digestive system is actually you So creepy, right? Okay, so on the other side of the scale, we have bases or alkaline solutions. Blood is slightly alkaline. Seawater is slightly alkaline. And then things like milk of magnesia, which is something that you take to counteract an overly acidic stomach, and heartburn, which is acid from the stomach flowing up into the esophagus. Milk of magnesia makes the stomach acid more neutral. Okay, when you mix an acid and a base, you get more neutral. Ammonia, bleach, oven cleaner, all strong bases, which are also very dangerous to living tissues. Okay, so here's a meme that I think is personally hilarious. Dihydrogen monoxide is an acid with a pH level of 7. That's a higher pH level than any other acid. And they've put a boiling beaker of water on a Bunsen burner to make it look really scary. So first of all, dihydrogen monoxide. Di means 2, hydrogen, 2 hydrogens, mono means 1, monoxide, 1 oxygen. Dihydrogen monoxide is water. It's an acid with a pH level of 7. That's actually not correct. A pH of 7 is neutral. It's neither an acid nor a base. Dihydrogen monoxide is neutral. But that's a higher pH than any other acid is true. But the lower pH is a stronger acid. So the reason this is funny is that they're trying to make water seem scary based on people's ignorance of what an acid is. So a strong acid is one that has a lower pH. A higher pH is less acidic, less dangerous. Okay. Buffers are anything in a solution or any solution that can either absorb excess hydrogens or excess hydroxides. It absorbs excess hydrogens or donates hydrogens. And a buffer can do that and maintain the pH of a solution. Your blood and seawater both have the ability to buffer somewhat. And so when carbon dioxide is added, for example, to ocean water, some of that carbon dioxide mixes with water and becomes what we call carbonic acid, H2CO2. So you take this H2, this CO2, release one of the oxygens, you get carbonic acid. That makes seawater more acidic. Remember that seawater is a little bit basic. As the ocean absorbs more CO2, some of the buffering capacity of the ocean absorbs some of this carbonic acid and turns it into water and releases some of the CO2. But some of it, it can only absorb so much. And so as more CO2 is present in the atmosphere of Earth, more of that air touches the water, that air dissolves in the water. The CO2 then binds with the water, creates carbonic acid, and it can overwhelm the buffering capacity of the oceans, and the ocean water becomes more acidic. Now that's going to really suck if you're a living creature trying to live in the ocean and you depend on the environment around you being a certain pH, which is why ocean acidification is dangerous. That is one of the many problems associated with the increase of carbon dioxide in the atmosphere and global warming, which we will come back to so much this semester. All right, so acids and bases. Strong acids have a low pH. Strong bases have a high pH. Water has a pH of 7. It is neutral. The pH is the proportion of hydrogen ions measured on a negative logarithmic scale. So high pH solutions have a low number of hydrogen ions. Low pH solutions have a high number of hydrogen ions. That's what you need to know about acids and bases.